question is from GATE 2018, Mechanical Engineering paper, set 2, question number 20. A hollow circular shaft of inner radius 10 mm, outer radius 20 mm and length 1 meter is to be used as a torsional spring. If the shear modulus of this material of shaft is 150 gigapascal, the torsional stiffness of the shaft in kilonewton meter per radian is dash. Let's write the given information. So it is given outer radius is 20 mm, inner radius is 10 mm. Shear modulus G of the shaft is 150 gigapascal. Now as these values are given in mm, let's calculate everything in Newton and mm units. So if this is gigapascal, let's convert it to megapascal, that is 150 into 10 to the power 3 megapascal, and megapascal is equivalent to Newton per mm square. Now we are being asked to calculate the torsional stiffness. Let torsional stiffness be Kt. It is defined as torque applied on the shaft per unit displacement of the shaft. If it's a linear spring, we have the stiffness to be force per unit displacement, where the displacement is a linear displacement. Here we have torque per unit angular displacement. Keeping T as it is and calculating theta from the pure torsion equation. Pure torsion equation is given as T by J equal to G theta by L equal to tau by R. Now we are interested in the first two so that we can get a value of theta in terms of T. From here we get theta as TL by GJ. Let's substitute it over here. So we have KT is equal to T upon TL by GJ, which is equal to, rearranging this, we get the value of torsional stiffness. Unit of this stiffness will be unit of torque kilonewton meter per radian, because radian is the unit of angular displacement. So it is kilonewton meter per radian. Let's calculate from this torsional stiffness from the given values. We have G as 115 to 10 to the power 3. Now J, that is polar moment of inertia of the shaft, because it's a hollow shaft, it will be given by pi by 2 into R naught raised to 4, that is outer radius power 4 minus inner radius to the power 4. If you know the polar moment of inertia for a circular section, you can just subtract the polar moment of inertia of outer section minus inner section. That's what is done here. Divided by L, that is length of the shaft, is also given. It is 1 meter. We can convert it into mm and substitute it here as 1000 mm. Substituting the values for radii, we have 150, 10 to the power 3 and 1000 gets cancelled, and 150 by 2 becomes 75. So we have 75 pi into R naught to the power 4, that is 20 to the power 4 minus Ri is 10 mm to the power 4. Kt is equal to, it is easier to substitute this value directly in the digital calculator. This will be calculated to 35.343 into 10 to the power 6. But the unit here is to be noted, it is Newton mm per radian, because all the values we have taken in Newton and mm, in terms of Newton and mm. That is why the unit turns out to be Newton mm per rad, but we need the answer in kilonewton meter. To convert the unit into kilonewton meter per radian, we must multiply this 35.343 into 10 to the power 6 divided by 10 to the power 3 to convert Newton into kilonewton, and 10 to the power 3 to convert mm into meter. Hence we have the answer as 35.34 kilonewton meter per radian. And we have to write the answer for 2 decimal places. We have 35.34. So let's fill in the answer. Torsional stiffness of the given shaft in kilonewton meter per radian is 35.34. To learn more about torsion, you can refer to NPTEL video lecture 18 torsion 1. It's from the course lecture series on strength of materials by Professor S.K. Bhattacharya. He's from Department of Civil Engineering, IIT Kharagpur. I hope the solution will help you clear your doubt. Thank you.